non-mutually exclusive events. Okay. Still, this probability shows that the idea of event A or event B. But the problem in this one is that these events are not mutually exclusive. They have some type of overlapping. So our Venn diagram shows probability of A, probability of B, and then this section in here is where both events are happening. Okay, and all of them are within the set of all probabilities. There's possibilities outside of our two events. Okay, in this case, oops, got that upside down. Okay, in this case, our union of the two, A or B happening, is the probability of A and B minus the probability of A and B actually happening. So we take out, when calculating this probability, we take out one of these. And the reason being visually, if we had colors, I guess actually I can show it very nicely with colors. What am I saying? So we have yellow, okay? And the first time I go around this, you can tell that the yellow is taking up. It's actually accounting for A, B, because wherever they overlap, that's all within that first set. Now, when I do green, right now, technically, this would be okay if I did it like this. But in order for me to find the probability of event B without AB, well, we don't normally calculate probability like that. We calculate probability of all possibilities of B. So what you notice happens is we get an overlapping of colors. I was hoping for like a more pronounced color happening. We'll do something like this. Nope, that doesn't work. Oh, geez. Okay, that's the idea. Okay, so we get an overlapping. In other words, what has happened is we've double counted the A and the B. We counted it when we did the probability of A, and then we counted it again when we did the probability of B. So we actually only subtract one. We only subtract this once, probability of A and B, and that gets rid of the idea of our double counting. Can I undo that? Perfect. That would get rid of our double counting because technically we count it twice. So if you subtract once, then we've only counted it once, and then that works out great with our probability, and everything that's colored is what we're actually finding. That's why we have to do that subtraction. So what's the probability of a die turning up an even number or a number greater than 3? So important info. Looking for even numbers or number greater than 3. Okay. A little more straightforward. We know that a die has a possibility when being ruled of 6. Okay, there's 6 possible options. So we'll call this event A and probability of event B. We'll call that event B. So let's change our thing here. Our probability of event A. Well, if we look at our options on a die, you have 1, 2, 3, 4, 5, and 6. Okay, they're looking for even numbers, so you got 1, 2, 3. So you got 3 possible options for the first probability. Does that idea make sense?
Yeah.
Okay, that works out nice. Our second probability of event B, it's an A, probability of event B, we're looking for numbers greater than 3. Okay, well we have 1, 2, 3, 4, 5, 6. And they said greater than 3, so they're looking for 4, 5, and 6 in this case, which means the probability of the event happening are, again, out of 6, there are 3 total options, so it's a 3 and a 6, so half, right? The problem is, let's see if I can get this to do it. You can tell here, there's a bit of overlapping, okay? You'll see that we have overlapping with 4 and 6, okay? So if we were to draw a Venn diagram, these are the values, and we can actually probably quickly do that, right? The possibilities. We had we had options of probability of A were even numbers, right? So we're looking at 2, 4, and 6. And then numbers greater than 3 were 4, 5, and 6, okay? So there's that idea of 4 and 6 being double counted when we look at our probabilities here. So we have to figure out what's the probability of A and B happening. And what is the probability of A and B happening? Do you know what that is? Probability of A and B. Okay, it's out of 6, that's right. How many of the numbers? Twice. So 2 out of 6. So now that we have these ideas, we can find our probability of our union. Okay, so we take the probability of A, we add the probability of B, and we subtract the probability of A and B. So we calculated above, probability of A is 3 out of 6, or I'm just going to write it as a half. Okay. So we have a half plus the probability of B is again a half. And then we subtract by the probability of A and B, that's technically a third. I'll write that in green. Okay. So we have to actually do the calculating. Now, obviously, it would have been better if I left everything as a denominator of 6, so I'll rewrite it. Minus 6 minus 2 out of 6. We keep the denominator the same. 3 and 3 would be 6 out of 6. Subtract 2 out of 6. And again, we end up with 4 out of, out of 6. So the probability of both getting an even number or a number greater than 3 is 4 and 6. And let's take a look at this. Let's think of this intuitively. Even numbers are 2, 4, 6. So there's 3 of them. And then greater than 3, the only number we're missing out is 5. So there's 1, 2, 3, 4 out of the total 6. So we have our 4 and 6 probability.